It's now time for a sample chemical equilibrium problem. It begs the question, what can you do with the KEQ, the equilibrium constant formula, sometimes known as the equilibrium constant expression? And also, how do you know in general when you've achieved chemical equilibrium? How can you tell? This is Screencast 14.3, and let's get started. Okay, our sample problem. We are taking some hydrogen sulfide and we are reversibly decomposing it. That hydrogen sulfide is turning into its elements, hydrogen and sulfur. I suppose it would go from horribly smelly to more or less odorless, although I suppose the sulfur itself does not have the world's most pleasant smell. The equilibrium constant is very low. Let's go ahead and set up this, let's define the problem first. Here it is. If the concentration of sulfur is that, and the concentration of hydrogen sulfide is that, what's the concentration of hydrogen? Isn't that interesting? We can use the equilibrium constant expression to find out how much any of these reactants or products are in there at equilibrium if we have enough other information. So that's one of the things you can do with it. You could also figure out the equilibrium constant expression if you knew everything else, the concentrations of everything at equilibrium. Meaning, like for any formula, if you have most of the other values, you can solve for the unknown. So let's set it up. The concentration of the products. Notice we have to square hydrogen and divided by the concentration of the reactants. That also has to be squared. We can then plug in the numbers. There it is, 0.054 for sulfur, 0.184 for hydrogen sulfide. That better be squared. Good. And now you have enough to solve the problem. I did skip the algebra for this, and it's a kind of a pain. You know, you're going to have to take the square root of hydrogen at some point. But anyhow, you can go ahead and mess with these numbers, and you should find that the concentration of hydrogen is very low, 0.0377 moles for every liter. And that's a sample chemical equilibrium problem.